In this lesson, we will be factoring by grouping. So first of all, we will review our factoring that we did in our last section. So let's take a look at problem number 1. There is not a greatest common factor, and it is a trinomial, so we are going to create our x. A times b, or excuse me, a, b, c. A times c would be -4. B value is -3, so I would multiply -4 times 1 to get -4, and -4 plus 1 adds up to -3. And since the leading coefficient is 1, we can write our two factors. The next example, we have a greatest common factor, and when we divide, we have x squared minus 4, and then we know that that's a special pattern of the difference of squares, so it will be x plus 2 and x minus 2. In our next example, we have a greatest common factor of 3. So we have 3, and we have x squared minus 2x plus 1. It is a special pattern of a perfect square trinomial, but it is also easy to do with our x. So a times c would be 1, and we would have our b value of -2. -1 times -1 is +1, and when we add them together, we get -2. So don't forget your factor of 3, and then we have an x minus 1 and an x minus 1. Or we could write it as x minus 1 squared. So here's the factoring chart of all the methods we've used, and now we're going to move on to factor by grouping. When you're factoring by grouping, it must be a polynomial with 4 terms. So the method would be finding the greatest common factor for the first 2 terms. Then when we divide, we get x plus 2. Finding the greatest common factor for the next 2 terms, which would be -4. And now that you notice that these two are the same, we're really undistributing. So we're putting the 9x squared minus 4 as one of our factors and x plus 2 as our other factor. Noticing that if we were to distribute or FOIL, we would take 9x squared times the x and the 2 and the -4 times the x and the 2. We're undistributing. Can we continue factoring? Yes, because our first binomial is a difference of squares. So 3x times 3x would be 9x squared, and then we would have plus 2 and minus 2 as our product for -4, and then we have x plus 2 as our last factor. Okay, let's try a couple more. Step number 1. Find the greatest common factor of the first 2 terms. This will be 3x squared, and then we have x minus 4. Find the greatest common factor of the second 2 terms, +2. Remember, this only works now if these two are exactly the same. So we will combine the 3x squared plus 2, and our second factor being x minus 4. We cannot continue factoring 3x squared plus 2 because it's only a binomial, but it is not the difference of squares. All right, let's try the next 2. Find the greatest common factor and find the greatest common factor. These two are the same, so we will combine the x squared minus 9 and the x minus 5. And then we can continue to factor because that is the difference of squares. And now we've factored it completely. One thing I want to mention is that if it appears ever that these two factors do not have anything in common, even though they do in this example have a -9 in common, we want to make sure that you understand there would always be a 1 or a -1 in common in case that were to happen. So it's your job now to finish these last two problems and then to submit your notes.